Hello, my name is Christian Pillsbury. I'm a player engineer at Demuxed, and today I'm going to be talking about accessibility in media players. So what exactly is an accessible media player? At its core, what we want is a media player that's usable by as many people as possible, regardless of their situation. So that could include, for example, folks with vision impairments or motility impairments. There's a variety of distinct ones of each of those, and some of those might even just be situational. But what we don't want to do is assume that every user is going to perceive the media player in the exact same way, or that every user is going to interact with the media player in the exact same way. We still want it to be usable for those folks. So how do we accomplish that? I think we can break it down into steps, and probably the easiest first step is going to be making sure we have solid keyboard interaction. That can be broken down into three pieces: navigation, focus, and control. So a few things to note here. If we look at the player here, we can see that the currently focused element is going to be indicated clearly via a border. That's pretty different from a standard clickable design where you normally wouldn't want that to show up. That's so that you can know when you're interacting with a particular component. In addition, you want to make sure that the tab navigation works and makes sense. You want to make sure that the order makes sense, even if you have surprising layouts. Finally, you want to make sure that the way that you can control the controls is intelligible for a standard user. So if I'm interacting with a button, for example, I would expect to be able to press a space bar or press enter, and that would click that button, so to speak. Okay, so I said keyboard interaction, but really it's a much broader category. There's a lot of assistive technologies that are keyboard-like, or at least that simulate keyboard interactions or rely on keyboard interactions. This is why this is so important. For example, folks might be using things like alternative keyboards, mouth sticks, head wands, or even virtual keyboards using eye tracking. In addition, other assistive technologies such as screen readers and speech recognition tools are going to rely on keyboard interaction and implementation for some of their core functionality. So that's the first step. What about the second step? Here, we're going to have to dive into a standard that you might not be familiar with. It's called the Accessible Rich Internet Applications, or ARIA. Now, ARIA covers a lot of ground. We're not going to have time to go in depth on this, but we will come back around to aspects of ARIA later in the presentation. At its core, it's a bunch of attributes that allow things like screen readers and other assistive technologies to identify and interact with your components. In this case, the media player. There's a few core attributes that we're going to want to cover. First is the role. That's going to tell us the general type of thing something is. For example, we've got widget roles like buttons, switches, sliders. We might have some display only or aspect of the application roles like landmarks, for example, the region. And then we have some roles whose purpose is to allow things like screen readers to tell us what's going on, even if we're not focused on a particular element. Those are called live regions, and those include things like statuses and alerts. The second most important attribute here for ARIA is what's called the ARIA label. Again, this could be inferred, but we're going to talk about the concrete label. This tells us the specific type of thing something is or what it does. So while we might have a role of button, we might have an ARIA label of play, and that tells the screen reader that it is a play button. Okay? In addition, there are some other attributes that are going to be specific to particular widgets. For example, we've got things like ARIA checked, which would be used by, say, a switch or a checkbox to tell us whether it's on or off or checked or unchecked. We have other ones like ARIA value now and ARIA value text. These allow the screen reader to get additional information, including translating values into something that's more domain specific or intelligible to the user. So say translating a value into a time that is human intelligible, or translating a value into a percent if the thing being represented is a percentage. So here's a concrete example that I just talked through. We've got a media play button, its role is button, and the ARIA label is play. Again, we'll circle back around to this. So this is the high level of the attributes that are relevant. Now let's look at it as it's applied and how we should be using it. So if we look here, we've got a media player, and we want to make sure that each of the components has a clear role, especially the ones that are controls. And we want to make sure that they have a label that indicates the type of control they are. And then we also want to make sure that the values make sense. So we can see, for example, the play button is play. We've got things like the volume is at, say, 40%, not just 40, and that the seek bar is something like the time that is currently playing. So now let's see how it actually interacts with a screen reader. Here we've got an actual example using Apple's VoiceOver screen reader. And if we watch what happens when we interact with it via the keyboard, we see the closed captions is on, and then it turns to off, and then we see what the percent time is, and then we see what the seek time is, etc. Once you're done with these two steps, you should be able to check your work using a lot of built-in or third-party freely available tools. Each browser comes with its own accessibility auditing tool and even comes with investigation or inspection tools. So I highly encourage you to check those out. Very easy to install. And then you can start learning how these things work in a little more detail, and also finding out if you missed anything along the way. In addition, I've already mentioned Apple's VoiceOver. Pretty much every operating system nowadays comes with a screen reader, and some of them even come with voice recognition tools built in. So I encourage you to also check those out. They're another great way to see how it will actually work with an actual assistive technology tool. In addition, there are a few for money versions of screen readers and voice recognition tools that are fairly popular. If you can get to those, I would encourage you to check those out as well. So we've gone through these first two steps, but those don't really guarantee that the accessibility aspects of your player are really well designed. They ensure that you've met some requirements and that something will be usable, which is better than nothing. But what I think the next step should be is actually thinking about accessibility in terms of actual design. So in order to see that, let's start with just generic player design. One thing to note about player design is pretty much all the core player controls and components are consistent and ubiquitous. What I mean by that is, if you look at players, they all have the same controls, even across media types, whether it's podcast or audio playback for music. It's the same for physical devices. It's the same for things decades old, and even the same across multiple countries. There's even an international standard, of course there is, that defines some of these symbols. So what that means is these players are very predictable in how they're going to work, which means users don't really have to think about it. The player tells them how to interact with them because they're very familiar. All of the things work in a very predictable and intuitive sort of way. What I think is we can actually use that standard visual and clickable design to infer what the appropriate accessible design is as well. Because remember, these are actually drawing from physical designs that they're modeling via, say, metaphor. So in order to talk through this, let's actually take a concrete implementation example. We're going to talk about MediaChrome. Now, MediaChrome is a library and a set of components originally developed by Steve Heffernan, and the purpose of it is to make a completely agnostic set of components that can be used for players. That means they should work regardless of your particular player, and they should also work regardless of any UI framework you're using, say React versus Vue. Now, what I did was took these components and decided since these are supposed to be generic, predictable components that are usable anywhere, they're a good candidate for also trying to make generic, predictable, accessible designed components. So this again is using Apple's VoiceOver, and this is demonstrating what it looks like to interact with these components via Metachrome using things like tab and keyboard interaction plus the screen reader. And you can see that there's a bunch of different details, but we're getting various feedback that makes sense based on the components. So diving a little deeper, I mentioned earlier that the design of these things are actually based off of physical design and are metaphors for physical design. So an example of this are buttons. Most of the player controls, at least the core ones, are going to be buttons. But that might be misleading and might not tell you enough information because there's a variety of different kinds of buttons. So if we look here, we've got things like a momentary switch or a latching switch, which stays pressed when you press it and then press it again. And then we have an alternating switch, which still toggles, but it doesn't stay pressed. There's actually examples of each of those, I think, in a media player. And we're going to talk through some concrete examples and why. In addition, there are some other ones. We'll circle back around to one example of that. So here's an example of a momentary push button. We've got them highlighted over here on the side. They are the seek buttons. So when you seek forward or seek backwards, the reason they're momentary buttons is because you click them, one action occurs. You click them again, the exact same action occurs. So the way to represent that via ARIA is identifying them as a button and identifying the label specifically as a verb, because the button is representing something like push me and I will seek forward 30 seconds, which is exactly what the ARIA label is, seek forward 30 seconds. Next up is going to be the latching button. A clear example of that is going to be the closed caption button. So the way we can identify that it's a latching button is because it's something that even visually represents itself as pressed or unpressed. Generally speaking, latching buttons are representing something that is on or off, for example. So in that case, what we'd want to use not is a button roll, but instead a switch roll. And instead of using verbs like seek forward 30 seconds, we'd want to use a noun like closed captions. And then finally, we'd use the ARIA checked value to determine whether or not it's on or off. And we can actually see that what's happening is we've got a switch with closed captions and it's true or false. Okay. Next up is the alternating buttons. Now, you might be tempted to think of these also as switches, but I actually don't think they are. I actually think that they're representing something more like the physical world alternating push button. Here's why. They aren't actually representing something being on or off. Arguably, some of these you could model as like full screen on, full screen off, or mute on or mute off. But I actually think that that's less intuitive, and that's not what the physical design actually tells us. So if you look at these icons, taking the play and pause as a concrete example, what you're going to see is not that the button represents something as pushed or not pushed. Instead, what you're going to see is an icon that changes. And what that means is what the action that's going to be taken is changing and is represented by that icon. So, for example, when the button has the play icon, if I push it, that means it's going to play the video. If I then shows the pause button icon, if I press it, it's going to pause the video. So in that case, we want to represent it also as a button, but here we want to still use a verb just like we would with a momentary push button, but instead of one verb, it's going to change in a way that corresponds with the icon represented. So, for example, we'd have a button pause, play, we'd have a button mute, unmute, we'd have a button enter or exit full screen, etc. Finally, we have the weirdo button. It's the playback rate button. So this one's a little trickier to model because it doesn't directly correspond at least obviously with any physical button. We'll see later that there's a possible way that we could correspond it with something that's kind of like a button. But for now, what we're going to do is instead represent it more like an alternating latching button. So it's similar to old devices that had a button that would allow you to press through and go through a menu. So you would get to one menu state. So an example of this would be, say, a car stereo, and you press a button and it shows bass, and then you press the button again and then it shows fade, and then you press the button again and it shows balance. So that's kind of what this is modeled off of. So again, those are going to be nouns, not verbs, but they also change over time. So note this one, for example, will say current playback rate 1.25, current playback rate 1.5, etc. That's sort of one deep dive into this, but there are some other components that we've been exploring and implementing along the similar principles. So for example, we wanted to make sure that we added some human readable value text for things like the seek slider, representing it as minutes, seconds, etc., and that the volume is represented as a percentage. We also went ahead and added some display only components, such as making sure that the loading indicator is actually a live region. The reason I did that is because users might not know, especially non-sighted users might not know the reason why their video has stopped making sound. Many players fail to indicate to that user that a player is loading in the background. And then finally, as a possible implementation, we've implemented the time display as a progress bar. So it's, again, not an interactive control component, but the user could tab to it and find out where they are in the playback of the video. So that covers the high-level core components. There's a bunch of things that we're still looking forward to or exploring. I mentioned earlier that we were looking at the playback rate. So one possibility is modeling it as a spin button. That's kind of like a thumb wheel, if you recall those. The problem is I encountered some edge cases with keyboard control, especially when used in conjunction with screen readers. So might work out, but at least right now it's not. There's a bunch of other things that we might be exploring to try and make these things more consistent. One thing that's especially interesting to me is looking at the relationship between accessibility and internationalization, because we want to make sure that we're not assuming, for example, that every user of your media player speaks English. That's one example. In addition, we've got some other benefits that we can get from doing this effort, especially when it comes to ARIA. These designs should make things better for all users. As I mentioned at the beginning, you might just be in a situation where you need to use a keyboard instead of a touchpad, especially for things like Mediachrome. But regardless, as long as you're being consistent with these things, these concepts should be shareable for any component or aspect of a media player that is consistent. And as we've seen already, many media players use the exact same kinds of components with the exact same kinds of interactions. Moreover, you can get things like analytics can clearly distinguish between programmatic actions or QoS type things versus user intentions and user actions, because the components are actually identified as what kind of action is trying to be taken. And since it's a UI component, it's pretty likely that it's a user that's trying to control that thing. Finally, there's an added benefit of having very clear and predictable component testing, especially for the UI. And an example of that is Kent C. Dodd's testing library actually uses and encourages you to use things like ARIA roles. So this will work really well in conjunction with that. And that's my presentation. I hope that helped you get some context here, and let me know if you have any questions.